together on a Wednesday night and learn about you. And God, I thank you for each one who's committed this time, who's been obedient, and a good steward with their time to come out tonight, God. So we just pray that you bless them and their families. And God, I pray that you would be with us tonight. The things we're talking about are academic, but it's not just an academic issue, God. We need your Holy Spirit to understand these truths. And so we ask that you would be with us tonight. And I pray that you would be with me. And I pray that I would be articulate and clear in what I say. And then just be with me as I speak. In the name I pray. Amen. So why don't you shake with your hands? So let's get into this. Now that we've all been formally acquainted, what I'd like to do is I'd like to actually start, because it's been a few weeks. I know you guys were all studying up on this over the Christmas holidays, but I thought it might be a good idea if we just kind of review what happened in session 1, and then session 2, and then this is class number 3, session number 3, okay? And then this is it. As far as I'm concerned, you will have learned everything you need to know about the topic now. But this is all I know about it. So we're ending with session 3, and then the next 2 weeks, I'm actually going to be in here. So I feel a bit sorry for you because you get me for 2 more weeks. I'm going to be answering the question: are evolution and Christianity compatible? And if they are compatible, should we embrace evolution? Okay? It's a pretty controversial topic. It's a topic that I've done a little bit of studying on. I've written papers on. I've actually given lectures on at the university level. So, and I've actually taught high school biology. So if you're interested in that topic, I would encourage you to come out the next couple of weeks. Okay? I think it's the 15th and the 22nd. All right, so reviewing session 1. The first thing we learned in session 1 was that theists and atheists have the same what? The same
information.
They have the same facts, the same information, the same science, okay? They have the same science, but they're working from a different worldview. And that's why they come to different conclusions. It's not that the theist has their facts over here and the atheist has their facts over here. They're all the same facts, the same world we're looking at, okay? We come to different conclusions because we have different worldviews. And I talked about Francis Collins and Francis, oh man, I forget his name. The other guy. It's not James Watson, it's, yeah, Crick. And they both were a part of the Human Genome Project. One started and one finished it, okay? Both scientists at the top of their fields, and yet they come to very different conclusions. One's a Christian and one's an atheist. The second thing we looked at was the definition of faith. Within the church and outside the church, most people have no idea what faith is, okay? And so we said that faith, do you guys remember the definition of faith that I gave? Faith is active trust based on evidence, okay? Before I show you, I'm hesitating to show you because I don't want to give the answer away. But I said faith has 3 components. I'll give you 4 gold stars if you can name one of the components to faith. Oh, commitment. Who said that?
Your wife.
My wife's not allowed to participate. I'm gonna give these to you. The first one was faith as an object. If someone says I'm a person of faith, say great. You have faith in what? Faith is something you put. Faith is something you have in. Okay. And so an object. I said an airplane. You can have faith that an airplane will take you from Toronto to Florida or something like that. Okay. So the airplane would be the object. The belief that it will take you there. That's the content of your faith. And then finally, there's an actual commitment or the act of trust of putting yourself in. And I gave the illustration of that tightrope walker, and he had the wheelbarrow, he had the rocks in there. He said, "Do you have faith I can do it again, to walk across again?" The person said, "Absolutely, I've seen you do it a number of times." He poured out the rocks and said, "Okay, climb in." Okay? That's what faith is. It's active trust. Listen, I probably said this, but I have more faith in my wife today than I did 5 years ago when I married her. Because she's giving me more reasons to trust her, to have faith in her since we got married. Okay? And it's the same with your walk with the Lord. When you became a Christian, I hope that today you have more faith than you did then because of all the things that God's been doing in your life and how He's been showing Himself to you. And because of classes like this where we have reasons to trust Him and believe in Him. Okay, so that was faith. Very important. So blind faith and biblical faith are not the same thing. In fact, they're worlds apart. After that, we looked at the different ways science is being used. The term science is being used. Not only is it a methodology, the scientific method is what we teach kids from kindergarten onward, okay? The scientific method. But it's also being used philosophically. In fact, we call it philosophical naturalism. And where certain conclusions are not being permitted, okay? So when someone says that creation is not science or intelligent design is not science, they're not talking about the methodology, they're talking about the philosophy. They're saying no supernatural explanations are allowed. And I gave an illustration for that as well, but I can't reteach all this stuff to you, or we'd be here till, I don't know, forever. The fourth thing we looked at was we saw that God and science are not competing explanations in the same way that Henry Ford and the laws of internal combustion are not competing explanations for the engine. Okay? They can be different levels of explanation. And so we don't have to exclude one or the other. It can be both. We also said that the majority of scientists through history were actually theists. They actually saw no incompatibility between science and the supernatural. And I corrected the date there. Galileo, I don't know who pointed this out to me, but we had him dying before he was born. But so you have guys like Bacon and Kepler and Newton, and the list just goes on and on and on. And they all believed in God. And so I have no incompatibility between science and God. And was that it? Oh yeah, and then finally I gave one argument that argued that the rationality of the universe and the rational mind, the actual ability to study the universe, presuppose theism. I mean, if we really are just random chance, no design, then why would we really trust our minds, which are just the laws of chemistry reacting? In fact, all our thoughts are just physics and chemistry. That's what they are. And there's nothing else to it. Then why would we think that we could study the world? Not only that, why would we think that when we come up with ideas in our mind, that they'll actually match the world? And so I pointed out Nobel Prize-winning scientist Peter Higgs. 50 years ago, pen and paper formulated what he called the Higgs boson, and then we built a particle accelerator. Billions of dollars are spent on this stuff. There's countless scientists working on this, and 50 years later, we actually discover the Higgs field, the Higgs boson, what they call the God particle. And so the fact that that can happen in our universe, I think, points to God, is a very strong argument for God. But not only that, that was just session 1. Session 2, we went even further. Session 2, we first looked at the God of the gaps argument. Most people think that you and I believe in what's called the God of the gaps. What's the God of the gaps? Well, they'll say that you just don't understand the origin of life, or you just don't understand the fine-tuning of the universe, or you just don't know what brought the universe into existence, so you just assume that because you don't understand it, or it's too complex, therefore God did it. So it's an argument from ignorance. So you see all these gaps in this person's knowledge? He just says God did it. Oh, I don't understand that, so God must have done it. I don't understand that. So they'll give illustrations like superstitious people thought the thunder god, Thor. He's responsible for thunder. But then, as science advances over time, well, we discovered that it's actually rapidly expanded, rapidly heated air molecules that actually cause the noise you hear that we call thunder. So there you go. Natural explanation is thrown in the waste bin, and we have a natural explanation. And they'll think, given enough time, we'll explain everything naturally. Okay? The question is, and so we would argue, no, we're not making an argument from ignorance. It's not a God of the gaps argument. In fact, it's a positive argument. We're taking evidence from the 20th and 21st centuries. This is modern science, and we're showing that this positive evidence argues for God, the supernatural. Okay? And so there's a huge difference between those. And so I offered two arguments for God's existence so far. One is the origin of the universe. More precisely, the beginning of the universe. And I said that there's actually three reasons why we know from science the universe had a beginning. Okay? There's more than three reasons, by the way, which I'm not going to get into. Some of them get a little more technical, but here's just three. The first that I offered was, if you look at Einstein's equations from the theory of general relativity, this goes way back 1950, okay, when he published his work. And so you have his equations pointing to either an expansion or a contraction of the universe. It's not static. He knew what that meant, remember? He knew what that meant. And so he came up with a fudge factor, a cosmological constant that he put into his equation to keep the universe static. Phew, right? Now the universe is static. But then he realized that that was a huge mistake. In fact, he called it the biggest blunder of his life. And so Einstein's equations point to a beginning. They say that the universe, they describe the universe. I mean, how does an equation do that? The equation describes that the universe is expanding, okay? But not only that, the redshift confirmed it. Edwin Hubble, he actually made that observation, and there's a picture of Edwin Hubble and Einstein together. They found that all the galaxies, when you look out at the night sky, they're redder than they should be, okay? And that's called the redshift. Remember we talked about the wavelength of light being expanded because they're moving away, they're stretching, and that makes them redder. So that points that if they're moving away, go back in time, like play the movie in reverse, the galaxies are closer and closer and closer until you get to a beginning to the universe. There must be a beginning. The third evidence that we saw was the second law of thermodynamics. This is one of the most fundamental laws in all of physics, and it basically says that everything's running down. All the usable energy in the universe is running down. I said, think of a car, okay? There's a car running out in the parking lot. If you go out there, you know one thing for certain. You know it hasn't been running from eternity because it would have run out of gas by now. We know that it must have been filled up, the tank was filled up a finite time ago because it's still running. Likewise, our universe still has usable energy, therefore, it had a beginning. It had a finite point in the past when it started. And so those three evidences point persuasively to a beginning of the universe. And then I made the argument that the beginning points to a beginner. The second thing that we started talking about was, second evidence was from the origin of the fine-tuning of the universe. And we looked at all the fine-tuning right from the Earth all the way up to the universe. So we said, look at the oxygen level, it has to be just right. The planet's distance from the sun, the amount of water, 70% water, the density of water. Water is the only element that actually, when it freezes, it actually is less dense. So ice flows. And we talked about the importance of that. The size of the Earth, the tilt of the Earth. Remember, if you want seasons, it has to be tilted. You have the magnetic field. We said that acts like a shield, preventing harmful radiation. The position of Jupiter. Where Earth is in our solar system is just right for our survival. Jupiter is a cosmic vacuum cleaner. This is like in the textbook. We get to teach this to the grade 9s. It literally sucks in all the space junk so we don't get bombarded by asteroids and meteors and everything else. We looked at the position in the galaxy. So not only is our position in the solar system just right, third rock from the sun, but our position in the galaxy seems to be just right. Remember, we're not inside a spiral arm where it's very dense with stars. We're not close to the center where there's a massive black hole and tons of supernova and hypernova, all these exploding stars. So the position there is just right. Also, we're in a star cluster that only has a handful of stars, as opposed to most clusters have thousands, like 10,000 stars. We have 10,000 galaxies. We're in a group called the local group, and there's about 11 galaxies in it. And so in most of them, there's the 2 medium-sized galaxies, the rest are dwarf. But here's the 2 things that I thought were the most persuasive, and there's more like this, but I just offered 2. I said the gravitational constant and the entropy level. Let me just review those with you, because I think this is the most persuasive evidence for the fine-tuning of the universe, and I think it points persuasively to a designer. The gravitational constant, the big G in the equation, we teach that in physics, grade 12. The big G is called the gravitational constant. It has to be just right. If that gravitational constant is changed by 1 part in 10 to the 40th power, that's 1 followed by 40 zeros, our universe doesn't exist, okay? What happens is if it's a bit stronger, then our universe quickly collapses in on itself. If it's a little bit weaker, our universe blows apart, okay? And so I showed all the zeros, because that's more impressive. And then I compared that to the odds, other odds. Okay, so let's say the odds of being hit by lightning, and I know it was spelled lightning with an E before, so I changed that. The odds of being hit by lightning are 1 chance in 600,000. I put 1 in a million. The odds of winning the Lotto Max are 1 chance in 30 million. I think I put 100 million up there. The odds of being hit by lightning twice are about 1 in a trillion. That's 1 in a trillion you're looking at. And yet, the odds of getting the gravitational constant just right are all the white zeros that continue. Okay, 1 chance in 10 to the 40th power. Okay, that's not, you guys aren't impressed by that, are you? I mean, this is the gravitational constant. I mean, you can look at the speed of light, the cosmological constant. I mean, we could just go on and on. The strong force, the weak force. We could do all these things, but then I have to teach you what the weak force is. And so we're going to review the entropy level. Remember, we talked about second law of thermodynamics. And we said, what about that entropy level? Well, the universe is running down, so the car's running out of gas. This is Roger Penrose, Oxford professor, not a Christian. He says this. He says, namely, an accuracy of 1 part in 10 to the power of 10 to the power of 123. That's the odds of getting the entropy level at the initial creation event. Okay? He says, you have to have that amount. That's the odds of getting the entropy level just right. 1 chance in 10 to the 10 to the 123rd power. He says, you can't write that number out. Even if you had you wrote a 0 on every atom in the universe. There's only 10 to the 80th power of atoms in the universe. So what I did was, because I took data management, in fact I taught data management, it's a math course in grade 12, I thought, let me show you what that number would be like. It would be like this. Imagine I took a universe-sized jar. Okay, you guys done the jelly bean thing where you guess how many jelly beans? Imagine instead we had a jar the size of the universe, and all the jelly beans are red, except for 1. There's a blue one, okay? That would be the same. And I said, I blindfold you and I say, okay, pick the blue one. And just to make things interesting, I blindfold you and I put a gun to your head and I say, I'm going to shoot you if you don't pick the blue one. That would be the odds of picking the blue one would be 1 in 10 to the 80th power. But remember, our number is 10 to the 10 to the 123rd power. And so if you do the math here, and feel free to do it yourself, it looks like this. This is what it looks like. You pick the blue one, blindfolded, okay? Pick it out. Okay, we put the blindfold back on. Do it again. You pick it out again. Wow, this guy is lucky. Remember, this is life permitting, right? We're talking about life permitting universe. This is life permitting. Wow, you just picked it again. And then you do it 10 to the 121 one more times in a row. And then you do one more time. And if you did it all of those times in a row, blindfolded, that would be equivalent to our number, 10 to the 10 to the 123rd power. Okay? Listen, I don't have enough faith to be an atheist. I just don't have enough faith to believe that that just happened. But, I mean, literally, you have to have enough faith that the person, eventually, when they're pulling those blue balls out of the jar, you're going to say, "You're peeking. You're cheating. Aren't you? Aren't you designing the outcome here somehow? You're not that lucky." Listen, we're not that lucky. We're not that lucky. And so I don't have enough faith to be an atheist. In fact, I'm taking a course right now. In fact, I'm missing my course. I should be at my computer watching a live stream class right now. And the textbook we're using is called "I Don't Have Enough Faith to Be an Atheist." And so, nearly 2,000 years ago, Paul wrote at the beginning of Romans, the letter to the Romans, it says, "For since the creation of the world, God's invisible qualities, namely his eternal power and divine nature, have been clearly seen, being understood from what has been made, so that men are without excuse." Okay? And I think after showing that, everyone in here is without excuse. The evidence for a designer is certainly clear that there is a creator. In fact, there should be no surprise that David, the psalmist, wrote this in Psalm 19:1. It says, "The heavens declare the glory of God, the skies proclaim the work of his hands." Right? So he's looking up in the night sky. And that's not exactly what you'd see if you looked out in the night sky. That picture right there. Well, let me just show you what Isaiah says, because this is kind of cool. Isaiah says that, this is Isaiah 40, 25 and 26. It says, this is God speaking. Isaiah speaking on behalf of God. God says, "To whom will you compare me? Or who is my equal, says the Holy One? Lift your eyes and look to the heavens. Who created all these? Who brings up the starry hosts one by one and calls them each by their name?" And so that, I highlighted this guy here. What you're looking at, every single dot on here, except for this, on the screen here and here, those are all galaxies. Okay, those aren't stars. Those are galaxies. You want to know how they got this picture? This is called the Hubble Deep Field. There's actually, I got to update this because there's actually the Hubble Extreme Field or Extreme Deep Field or Ultra Deep Field. I forget what it's called now. But it's even more clear than this. What they did was they had the Hubble Space Telescope that's orbiting the Earth. They basically found a point in the night sky that was pitch black. And they thought, I wonder if there's anything out there in that darkness. And so they focused the telescope on this speck of darkness. Literally, they say it's like if you held a sand grain at arm's length and just like focused on it, that was that piece of darkness. Well, 11 days later, after just focusing their telescope on this, they end up receiving the image back. And what you're looking at, this is just part of it, is what they found. They found, in that piece of darkness, they found 10,000 galaxies. 10,000 galaxies. And remember, our galaxy has about 200 billion stars. 200 billion stars. And so what you're looking at is just a whole bunch of galaxies. So here's what you can do for your devotion tomorrow morning. Go to Google, type in Hubble Deep Field, okay? And you can look at the high definition photographs. So I'm just going to take you through. Everything you see, every speck is, except for these, there's no stars there. Those are all galaxies, all different shapes and sizes. If you kind of see the star looking like right here, that's a star. but everything else, the star kind of got in the way there. But everything you're looking at, those are all galaxies. It's pretty cool. Just to give you, remember, Isaiah said, look to the heavens, right? Look to the heavens. The heavens are awesome. Let me just describe what the heavens are like. We'll do a little thought experiment. So remember, the Milky Way galaxy has about 200 billion stars in it, okay? 200 billion stars. Now, the average distance between two stars is about 48 trillion kilometers, okay? Or 30 trillion miles, okay? That's the average distance, but just between two stars. Now, if you were to hop in the space shuttle, now I think they retired the space shuttle, and so here we have a space shuttle. They move at about 8 kilometers a second, so they move pretty quick. If you were to hop in a space shuttle and start flying to the nearest star, so you're going from our sun to the nearest star, it would take you approximately 200,000 years. Okay? That's to get from one star to another star. 200,000 years with our best technology. So you can imagine what it would be like to go to like another galaxy. I mean, this is just one star. I don't know if this thing burns up on. Yeah, no. Okay, so you don't want to land. You don't want to land on the. I have a kid's version, and I think it blows up or something. So here's just a couple photographs of what these galaxies look like. I really like this one here. This is called the Sombrero Galaxy. If you're on the sides, there's also, it's back here, that's what I keep looking at. I'm kind of distracted by it. Here we have a collision between two galaxies. They're literally running into each other. Okay? That's kind of neat. It's awesome. Some of this stuff. That's the Sombrero Galaxy. It's just taken with like infrared. There's a pinwheel galaxy up there. There's just a cluster of galaxies. It's kind of neat. So, just awesome stuff. Now this, I like this galaxy. It's not color, but this is called a globular cluster. Everyone say globular cluster. Who doesn't like saying globular? There's one person. There's always one. A globular cluster is a different kind of galaxy than ours. Ours is a spiral galaxy. It has some spiral arms. Globular cluster, that's just a cluster of stars. This globular cluster, a fancy name. This is called M4. M4. That's a fancy name. There's about 1 trillion stars in that photograph. 1 trillion stars. Okay? That's a lot of stars. What's cool about this is there's actually a planet right in the center of there. There's a planet there. And they found it, there's a long explanation for how they found the planet there. But they found this planet. I think this is cool. You couldn't live on this planet. The radiation would completely decimate it. But it would be wild to live on this planet because all you would see is suns all the time. Okay? Now, I would say 24 hours a day. I don't know what the day would be like there. But it would just be all the time light. But here's the problem with living on a planet like that. Do you ever see a problem with living on a planet like that, besides the radiation? You would never know that there is a galaxy outside of your galaxy. You would only know about the stars around you. You would never be able to see outside of it because it would be all light all the time. You guys know this. If you go to Toronto, you don't see any stars. It's not that the stars are gone. They're there. You just can't see them. It's light pollution. Now, if you go to Mount Albert or something like that, you know, one of the fields there where it's pitch black, you can just see stars. It's awesome. That's what David's talking about, by the way. He didn't, look up in a big city and just see clouds. No, he was looking at the stars. It turns out not only is our Earth finely tuned for our existence and our galaxy, all of that is finely tuned for our existence. But the fact that we can study our universe seems to be a finely tuned thing for us as well. The fact that we can make observations like these seems to be finely tuned. We're in a place in our galaxy, and in a galaxy that permits us to study the rest of the universe, which is actually pretty cool. So the heavens are awesome. A skeptic or an atheist could ask, or maybe a Christian could ask, why is the universe so big? Isn't it just a waste of space? I mean, we just looked at all this. If we really are the only ones out there, then it just seems like a total waste, right? Unless God's trying to communicate something, right? If you thought it was a waste, you'd completely miss it, okay? Because David again, Psalm 103:11 says, "For as high as the heavens are above the earth, so great is his love for those who revere him, or honor him, or treasure him." So you see what's going on there. David is comparing. For as high as the heavens are above the earth. Now don't have this in mind. David's not thinking about that. He's thinking about like what we just looked at with the deep field. Okay? As high as the heavens are above the earth. God's comparing his love to something. What will he compare himself to? He says, look to the heavens. Why are they so big? God's making a comparison. And so if we lived in a small universe, well then it would, God only loves me as big as this small, this universe. We can look at this universe and say, it's huge. How much does God love you? Look at the universe, right? That's why it's so big. But not only that, we're talking about God's love here. So we can look at the finely tuned universe and say, yeah, everything seems to be just right for our existence. God loves us that much. But he not only loves us that much, he loves us actually more than that. And we can read that in John 3:16. For God so loved the world that he gave his one and only Son, that whoever believes in him shall not perish but have eternal life. Right? He sends his Son, the second person of the Trinity, to take on human flesh. That's way bigger than everything we just talked about. Okay? That's bigger than the universe. And so we got to keep that all in perspective. So we're not just some ant farm. We don't serve a deist God that just sets things in motion at the beginning and then is hands off. And I wonder how this is all going to play out. I wonder if, how they'll relate to each other and that kind of thing. No. He wants to have a relationship with us. I think that's really cool. But what about objections to some of the arguments I've given? So let's look at some of the most powerful objections that are out there and see how our arguments hold up. So let's start with the objection from Richard Dawkins. He made this objection popular in his book, The God Delusion. Okay? This is probably the most common objection that you will hear to both the evidence for the origin of the universe and the fine-tuning of the universe. It looks like this. Page 57, 58, in a chapter called Why There Almost Certainly Is No God, Dawkins says, the designer hypothesis immediately raises a larger problem of who designed the designer. So I give all this argument for the fine-tuning. Yeah, but who designed the designer? Or you have someone like Lawrence Krauss. He's a cosmologist. I just wrote a very long paper on this gentleman and Stephen Hawking. And he said this in his book, A Universe from Nothing. He says this, ultimately many thoughtful people are driven to the apparent need for a first cause. Nevertheless, the declaration of a first cause still leaves open the question, who created the creator? Who designed the designer? Who created the creator? After all, what is the difference between arguing in favor of an eternally existing creator versus an eternally existing universe without one? Now that's a very strange last comment from Krauss, because I don't know of a single cosmologist who believes in an eternal universe. Okay? So it's just very strange that he would say that the universe is eternal when all the evidence points to it having a beginning. But what do we do with something like this? Who designed the designer? Who created God? Well, here's how I respond. First, intelligent design explanations are accepted in science even if the designer is unknown. Did you guys know that? If you stumble into a cave and you find these, those are arrowheads, you can know that they are designed, they're carved by intelligent people without knowing who that people is or are. Okay? You can know that. You can't say, I mean, Dawkins would have to say, whoa, you can't say that those are arrowheads carved by people unless you tell me who designed the designer. Who are the people? You've got to explain those people. What about this? What if we found machinery on the dark side of the moon? So there's one side of the moon that's always dark because of its rotation. We can't see it. Imagine we went back there and we found a space shuttle. I mean, it was like alien technology. What would Dawkins say? He'd have to say, well, you can't say that that machinery is intelligently designed unless you tell me who designed the designer. Begs the question, who designed the designer? In fact, this really hits home because there's a program that millions of dollars is spent each year on the SETI program. Do you guys know what the SETI program is? SETI stands for the Search for Extraterrestrial Intelligence. SETI. And they point these telescopes and satellites up into space, and they're looking for a signal. In fact, Carl Sagan had a video. There was a movie. What was it called? Contact. Yeah, there's a whole movie based around this. It's a real science program. That right there is in Puerto Rico. That radio telescope is 300 meters across. They built it inside this little valley. And literally, they're pointing out and they're looking for a radio signal that's going to come back with intelligence. In the movie Contact, it was all the prime numbers that came back, and they knew there was intelligence out there. That'd be tricky to find, prime numbers. If there was like a Shania Twain on there or something, you'd know. There's intelligence out there. I don't know why it's a Shania Twain. Miley Cyrus? No intelligence. They were just, no. Keep looking. But listen, the whole premise of this program is to search the heavens. If they find something, a radio signal that comes back, and they recognize it as intelligence, you know what they're going to say? There's intelligence out there. There are beings out there that are intelligent, that have sent this signal. But Dawkins, again, he would have to say, you can't say that, because you have to know who designed the designer. In fact, this would destroy all of science altogether. If we look at the universe here and we say, okay, well, we have an explanation, Dawkins is going to say, well, you need an explanation of your explanation. And then if you say, okay, I got an explanation for my explanation for the universe, he'd say, no, you need to tell me the explanation of the explanation of the explanation of the universe. And this would cause an infinite regress. You'd never know anything in science. Okay? So this whole who designed the designer argument seems to go nowhere. In fact, you can end the regress by simply saying that God is the necessary explanation. Okay? He is the necessary being on which you don't need a further explanation. In fact, you remember I quoted Lawrence Krauss. He said, can't we just say the universe is eternally existing? That's like the necessary thing, and you can stop there. That's what he wants to say. So why can't God be that? But even another approach to answering this question would be just to say that it's a logically incoherent question. Just to ask the question, who designed the designer, referring to God, is logically incoherent. It would be like, so William Lane Craig, he's a Christian philosopher, he says, God is an uncreated, undesigned, eternal being. And then Dawkins says, yeah, who designed the undesigned being? Do you see how that is logically incoherent? It would be equivalent to me saying, who's the bachelor married to? Who's that? Here's the question. Who is that bachelor married to? Bachelors, by definition, are non-married. They're not married. So to ask the question, who is the bachelor married to, is logically incoherent. If I said, how many corners does a circle have? That's logically incoherent because circles don't have corners. Okay? So, how many right angles or something like that? I have a bigger bone to pick with Dawkins, because Dawkins wrote a book called The God Delusion. He did write a book called The Created God Delusion. Listen, if Dawkins wrote a book called The Created God Delusion, I would be right there with him, because we have a name for created gods. You know what we call them? Idols. Good. But he didn't write a book called The Created God Delusion. He wrote a book called The God Delusion. He centered the whole thing around the Christian God, the biblical God. Okay? Feel free to read the book. But if he had done his homework, he would know that the Christian God is not a created God. The Christian God is an eternal God, uncreated. And so, there's so many verses. I just grabbed one. Psalm 92 says, before the mountains were brought forth, or ever you had formed the earth and the world, from everlasting to everlasting you are God. God's eternal. So to ask this question is like, it leaves me scratching my head. Like, what are you talking about? Our God is not created. So why are you asking who created him? I don't know. It seems strange. So let's leave that aside. I think we've dealt with it. What you'll often find is there's all kinds of theories that get put forth that try to explain away the finite universe, the beginning of the universe. They want the universe to be eternal. One way they do that is to say, well, maybe there's an oscillating universe. What does that mean? So they'll say, okay, there was a big bang, but there's going to be a big crunch. And then it's going to follow by a big bang and a big crunch, and a big bang and a big crunch, and a big bang, and it just goes on forever. Eternal. That would be an oscillating universe. So they propose that to say, look, now we've got an infinite universe again. No need for God. Okay? I'll address that in a second. Show that doesn't hold up. There's the baby universe theory or bubble universe theory. This is really strange stuff. This is like science fiction stuff. They propose that maybe inside a black hole, you've got this energy being kicked in there, and that kind of, they use the term wormhole. Now, wormhole is like a science fiction term as far as I'm concerned, but there's a wormhole that literally breaks into like another dimension and creates another universe. And that universe, you can kind of see them kind of bubbling out. Well, it kind of bubbles in, and you cut the umbilical cord. That's why they call it a baby universe. And then that universe kind of floats off on its own. Yeah. What? Even Stephen Hawking, who is an expert in black holes, says, and I quote, and because he wanted this theory to work, and in 2004 he said, there is no baby universe branching off. Okay, let's just leave that as science fiction, because that's what it is. But here's the deal. In 2003, there is a theorem called the Born-Guth-Vilenkin theorem. Okay? Now, I'm not going to give you all the details, but these three men, none of which are Christians, so you got Alvin Borg, Alan Guth, and Alexander Vilenkin, they were able to prove that any universe that has on average been expanding throughout its history cannot be infinite in the past, but must have had a past space-time boundary. That's what they concluded. In fact, Alexander Vilenkin, I'm pretty sure he's an atheist. So he's not sympathetic with my conclusion that God exists from the beginning of the universe. But he actually said this in the quote there. He said, "It is said that an argument is what convinces reasonable men, and a proof is what it takes to convince even an unreasonable man." He says, "With the proof now in place, cosmologists can no longer hide behind the possibility of past eternal universe. There is no escape. They have to face the problem." I don't think it's a problem, but they have to face the problem of a cosmic beginning. They call it a problem because they got to, who caused it, right? And that leads to God. But and this theorem has applied since. And so as far as I'm concerned, all of these models that seem to get put forth, and there's quite a few, they don't seem to hold any water. So let's move on from there. Let's look at this how do they answer the fine-tuning? The fine-tuning, there's a couple ways to get around it. I'm going to come back to this multiverse idea. But before we get there, there's something called the weak anthropic principle. And it looks like this. One strategy for countering the fine-tuned evidence says, of course the universe is fine-tuned for complex life, otherwise we wouldn't be here to notice our good fortune. Of course it's finely tuned. If it wasn't fine-tuned, then we wouldn't be here, right? Does that make sense? If it wasn't fine-tuned for life, obviously our life wouldn't be here. And so different people have put forth this kind of response. There's a couple things wrong with this response. One gentleman, his name's John Leslie, he's a philosopher. He came up with this illustration to show the absurdity of this challenge. He says, now imagine that you are in front of a firing squad of 100 trained marksmen, and the captain gives the orders. He says, ready, aim, fire. You hear the deafening roar of the guns. But to your surprise, you're still alive. And you look around you, it's like one of these cartoons, and there's like bullet holes completely surrounding you. All 100 trained snipers missed you. And one of the friendly guards to your right or to your left, he says, it looks like the firing squad has conspired to miss you. They planned, they designed the outcome to miss you. And then you say, this would be the weak anthropic principle, no. This is just dumb luck after all. If they hadn't all missed, I wouldn't be here to comment on my good fortune. If they hadn't all missed, well then I wouldn't be here to notice that they all missed. That's the weak anthropic principle. What they're doing, what this amounts to is this. They offer they offer a necessary condition instead of a sufficient cause. The necessary condition is, if the universe was not finely tuned, then we wouldn't be here. Instead, so they point to a trivial condition, obviously we're here. Instead of pointing to a sufficient cause, they don't explain the cause of the fine-tuning. What caused the fine-tuning to be there in the first place? You see how they just it literally is like they sidestep the issue. It's like just dodging the question. So I got all these things that are finely tuned. Can you explain? And they'll say, well, obviously it's fine-tuned, or we wouldn't be here to talk about fine-tuning. Okay, you just changed the subject. I want to know, how do you explain? What's your cause for the fine-tuning? And so that's one way they dodge the question or change the subject. So that's called the weak anthropic principle. Dawkins held this for a time. Now he's come out and he's affirmed that this is not a very good explanation. But what he does is he takes this explanation and he says, yeah, it's okay if you add to it the multiverse. Multiple universes. So we have our universe. Now imagine an infinite number of universes. Okay? And if you have an infinite number of universes, then eventually you're going to get one that's finely tuned, because there's so many, right? And so they'll say, the response is, our universe is just one of countless billions of universes just popped into existence, and so ours just has the right parameters for life. So rather than conclude that the fine-tuning is due to a single designer, rather than concede a single designer, they are willing to accept an infinite number of invisible universes. Okay? Which, by the way, have no evidence for them, nor could they have any evidence for them, because we're trapped in our own universe. You see the problem? If you can now study something with science out there in the universe, it's no longer another universe, it's in our universe, so it's our universe. So this becomes not a physics problem, it becomes a metaphysics problem, okay? And so there's a number of difficulties with the multiverse. One is that there is no evidence for a multiverse. It's essentially a blind leap of faith. It violates Occam's razor. I didn't put this point here, but basically you should take the explanation that has the least number of ad hoc things kind of thrown into it. And so the simplest explanation would be a single God than an infinite number of universes. But besides that, here's an explanation. This violates what's called the gambler's fallacy. And let me try and illustrate this with an example. Imagine two cowboys are playing poker. Okay, two cowboys are playing poker. You got Billy Ray Cyrus, and Achy Breaky Heart, that guy, and Tex. They're playing the Southern Texas Saloon, and every time Tex deals, he gets a royal flush. And Billy Ray, he's not the brightest guy. He says, you know what? After 3 times in a row. Because after 1 royal flush, well, that was the probability. After 2, it's about, well, you can see the number there. 3 royal flushes in a row. The chance of getting that is pretty rare. So Billy Ray says, you know what? You're cheating. And he pulls out his, shooting iron. Is that what they call it? Fire iron? I don't know. And he says, no, I ain't. No, I ain't cheating. He says, in a multiverse, there's an infinite number of universes with an infinite number of poker games going on, and I just happen to be in the lucky universe where I deals myself 3 royal flushes. What do you say to that? Yeah, in an infinite number of universes, anything can happen, can't it? Anything can and will happen in an infinite number of universes. But if I'm playing poker with Tex, I'm saying, you know what, you're designing the outcome, you're cheating. And I would say that's intelligent design, what's going on there. And so this is the gambler's fallacy, just to insert an infinite number of universes to kind of explain away the fine-tuning is what it does. And so that's another fallacy that comes up quite a bit in these discussions. The last thing I want to talk about, I want to switch gears here. I want to make an argument for the origin of life. But maybe what I'll do, let me give you guys, can I give you 3 minutes to stretch? Or is it too late? You guys are past this point, design or creation or whatever you want to call it. I'm going to look at DNA in more detail. What I'll do tonight is I just want to show you guys what it takes to build a cell, okay, a single cell. But just looking at building a protein actually. But before we do that, let me show you some quotes. Here's Francis Crick. You know what, it was James Watson. This is Francis Crick. At the beginning of the talk, I was pointing to the gentleman, and that was James Watson. Francis Crick, co-discoverer of the DNA molecule, said the origin of life seems almost to be a miracle. Almost to be a miracle. So many are the conditions, and we're going to look at those conditions, which would have had to have been satisfied to get it going. Stuart Kaufman is an origin of life researcher, theoretical biologist. He says, anyone who tells you that he or she knows how life started on the Earth and he says 3.45 billion years ago, is a fool or a knave, that is a dishonest person. He says nobody knows. He's speaking of a natural explanation, by the way. And so, why is it that nobody knows when life begins, or Francis Crick, why does he call it almost a miracle? Well, I want to demonstrate what these gentlemen are talking about. To get the simplest form of life, you have you need about 250 to 400 proteins to get the simplest form of life, like an amoeba or a paramecium or something like single cell, okay? You guys are multi-celled organisms. You have all kinds of cells in your body, different types of cells. This is a one-celled organism. 250 to 400 proteins. Each protein is made up of amino acids, okay? And so there are about 300 to 400 amino acids in a protein. So life is made of proteins, and more fundamentally, so a protein is made up of amino acids, okay? Turns out there are 20 amino acids that are used for life, okay? 20 amino acids that are used to build life, okay? You can almost think of them as like 20 letters of the alphabet, okay? Like its own alphabetical language, okay? What I'd like to do, I'm not going to build a cell tonight. What I'd like to do is just build a protein. Remember we said 250 to 400 proteins are to make up a cell. Well, what I'd like to do is just make one of those proteins, okay? And that protein is not going to be a very big protein. I want to make a protein that only has 150 amino acids. So half the number of the average size protein. Let me show you what I mean. Before I do that, I got to give you kind of a little tutorial on what's called combinatorials. It's a tongue twister. You guys actually know this, probably intuitively. If you guys were to lock your bike up, I don't know how many of you guys own bikes anymore. I had a bike. What happened to it? That's my track. I had one. I don't know what happened to it. I have a bike lock for it. Which bike lock is a better bike lock? Which one's a better bike lock? The bottom one, because there's more possible combinations, and remember, there's only the one that unlocks it. So here's how combinatorials work. Each one of these sites, we'll call them, this has 4 sites. Each one has 10 possible numbers. And so if you want to know how many possible combinations, it's 10 to the 4th power, okay? That's how many sites. If you have 10, I just photoshopped this. It's basically the same thing, just, I don't know if you can tell that. But it's 10 to the 10 because there's now 10 sites, okay? So that was just a little review because it's going to become very important when we build our protein. So we're going to build a protein that has 150 amino acids. Now here's our first problem. There's 3 problems we're going to look at. They're recognized by biologists. The first is called the chirality problem. Does anyone know what chirality means? It means handedness. All the amino acids in life are not right-handed. Are there any left-handed people here? This is your time to shine. Because all the amino acids that make up life are left-handed, okay? And so here's the deal. When we make amino acids in the laboratory, they always come in a 50-50 mixture, right-handed, left-handed. Well, we need all left-handed, so let's get rid of those right-handed guys. It turns out, if we're going to build our protein here, we need 150 left-handed amino acids. So there's number 1 amino acid. We need number 2. It's got to be left-handed. You got to do it again, all the way up to number 150. All of those amino acids have to be left-handed, okay? And so it turns out that it's really a 50-50 chance. It's like flipping a coin. So it's like flipping a coin 150 times in a row and getting heads every time, okay? Maybe tails every time. Okay, so you flip it, heads, perfect, we're on our way. Flip it again. Oh my goodness, 2 heads in a row. We're gonna build this protein. Flip it again. Oh, we gotta start again. We got a right-handed. We got a tails. Okay? So literally, the probability of getting to build our protein is 2 to the 150th power. Okay? 2 possible combinations. Remember? 150 sites. Think of the bike lock. You can convert this to the power of 10, which is 10 to the 45th power. That's 10, that's a 1 followed by 45 zeros. Okay? That's the chances of getting all left-hand amino acids. Now, normally when I do this, you guys know those kids' toys, they link together, and they're all different shapes, but they all kind of connect together. I don't know what they're called. I tried Googling it to get a picture, and Google doesn't even know what they are, okay? And so, and I have them, but I forgot to bring them. So it'd be like, here's our first one, and it connects in. Oh, perfect. We got the, maybe it doesn't go to that. And so, nice, those 2 left-hand amino acids are together. Then we got our next one, and it kind of joins in there too. You got to do this 150 times. And the only way this works is if they're all left-handed. You get a right-handed one in there, the thing doesn't fold properly. Okay, it doesn't work. Because a protein is going to do something in the cell. Okay, it has a job. Just like a hammer is a certain shape so that it can hammer nails into the wood, and a saw has the teeth and it cuts through. Well, you don't use a hammer to saw something. You don't use a saw to hammer something. Maybe some of you do. I know Pastor Don might try. He's not here, so I'm going to say something. So that's why it's important. Okay, so that's the chirality problem. Everyone say chirality. Okay, so that's the first problem. Here's the second problem. I said there's 3 problems, and we're just going to heap these on each other. This is called the bonding problem. If you want to make a cell, it has to have the bonds in between the left-handed amino acids. The bonds have to be peptide bonds, not non-peptide bonds. And it turns out that the bonds form kind of in a 50-50 chance as well. And so if you look at all the peptide bonds in between, now there's not going to be 150, there's going to be 149, because they're all in between, right? And it turns out there's 2 possible combinations, 149 sites, 2 to the 149th power, that's equivalent to 10 to the 45th power. So here we have it, guys. Not only the chirality problem, but the bonding problem. If you're going to do this naturally, you've got to get those 2 things right. You get the wrong bond, you get the wrong chirality, then end of story for your protein. Remember, this is just one small protein, 150 amino acids. Normally it's 300 and 400. Here's the biggest problem of all. It's called the sequence problem. Not only do your amino acids have to be all left-handed, they have to be in a certain order. Just like when I write words out, the letters have to be in a certain order or I misspell words and I don't communicate. Well, it turns out that if you want to get amino acid 1 and 2 in the wrong order, then our protein doesn't fold properly. I'm just saying hypothetically here, okay? So it turns out, if we work this thing out, this one's a little bit trickier to understand, but follow me here. There's 150 sites. There's actually 20 possible combinations for each amino acid, okay? That's used in life, those 20 left-hand amino acids for life. And so, you get a huge number, 20 to the 150 power. Now, and that changes to 10 to the 195th power. Now, this isn't the end of the story. Because if you there's actually more than one way that the amino acids can be in an order. And to illustrate that, I just took a word like the letters G-O-D. The letters G-O-D can be rearranged in 6 different ways, right? And I've shown them all here. But you can actually get 2 real English words with the letters G-O-D. You can get God and you can get dog. So there's 2 possible functional words, but there's 6 total possible words. So what these scientists have done is they found that possible functional folds over the total possible, which was at 20 to the 150th power. So the total at the bottom, but the number possible at the top, that gives you 1 chance in 10 to the 74th power. So what does this all mean? It means that the sequence problem, the bonding problem, and the chirality problem, when you add them all up, well, that makes getting life very, very difficult. It's actually a chance. Actually, this is just for a protein. Remember, I said life, but just for one protein, you're looking at taking all of these problems together to get 10 to the 164th power. Remember, I said there's only 110 to the 80th power of atoms in the entire universe. So you can see why someone like Francis Crick says it's almost as if getting life is a miracle. In fact, Dawkins was asked in the movie Expelled, and I was just reminded of this. They said, how did life come about? He says, I don't know. And what he resorts to saying, you can watch the clip online, he says, and he's not alone in saying this, there's a number of scientists who are saying this now, that life didn't actually start on the planet. It couldn't have, because there seems to be some intelligence involved. And so they'll say it was seeded by some kind of intelligent, alien or something like that. In fact, you can read the textbooks. This is a theory called panspermia, which is where life came from another planet and was seeded on ours. Okay? And so some people recognize the insurmountable problem here. And this is nothing. Remember, this is just a protein. This is nothing compared to getting a single cell. Not only is this a problem, but if you guys stay tuned to next week and the week after, I'm going to be talking about DNA. Now, DNA is like a language system, okay? A 4-letter language. And it turns out that that has to be in a certain order as well. Very similar to this. And when you see language like Mary loves John on the beach with a heart around it, you don't say, look at what the waves and wind and erosion did. You say, no, I recognize that's a J. And that next to it is an O, and then next to it is an H and an N. Hey, that spells John. I know what that means. And then Mary, oh, they love each other. I know what that means. Well, similarly, when you read, and we've now sequenced the entire human genome, we're talking about 3.5 billion nucleotide bases. This is a language. And you'll see that the problem just gets worse. Where do you get DNA from? The origin of life. In fact, the origin of life is equivalent to the origin of biological information. Where did the information come from? The only place we know where information comes from is from minds. You read a computer program, there's a computer programmer. You read a book, you read the words in a book, that's from an author, from a mind. Okay, not an explosion in a printing press or something. And so this, I think, is a positive argument for God, for a supremely intelligent designer for the origin of life. Oh yeah, I was going to show you all the zeros. That's and so let's hold on for maybe one more minute here. Anthony Flew. This guy is the most famous atheist of the 20th century, maybe who ever lived. Okay, he wrote a book called "There Is a God" before he died. But before that, in an article, he says it's become difficult even to begin to think about constructing a naturalistic theory of the evolution of the first reproducing organism. And then his book, what I think the DNA material has done is that it has shown by the almost unbelievable complexity of the arrangements which are needed to produce life, that intelligence must have been involved in getting these extraordinary, diverse elements to work together. And so this is a man who spent his entire life arguing for atheism. He has more published work on atheism than any other philosopher. He's the real deal. Dawkins, that guy, he's a biologist. He stepped way out of his field of expertise when he wrote The God Delusion, and many academic atheists have asserted so. Don't just take my word for it. In fact, a guy like Anthony Flew, who passed away before this book, probably would have affirmed the same. But this man actually changed his mind. In fact, if you read the subtitle of his book, it says how the world's most notorious atheist changed his mind. You can go on YouTube and watch him debating theists, okay? So, I mean, you can see he was an atheist for most of his life, and then at the very end, he didn't convert to Christianity as far as I know, but he did say this is the most powerful argument, this and the design argument that we looked at for the fine-tuning, changed his mind on it. In fact, his big thing was following the evidence where it leads. He always said in his debates, and you can watch them online, I follow the evidence where it leads. And it turns out he wasn't just saying that. He literally followed this evidence and that took a lot for a man like that, who had basically invested his entire life into arguing for atheism, to do a 180 and say, you know what, I was wrong on this stuff. And so, you know, I thought there'd be time for questions, but there is just no time for questions. I didn't think I prepared that much material, but I guess I was long-winded. So let me just pray for you, and if you want to stick around, you can ask questions, but I know the kids are going to be dismissed, so let's pray. Father, we thank you for this time that we were able to share together. I pray that some of the things that were communicated would be understood, if not all of it. I pray that this material would be used for your glory and to build your kingdom. I pray that everyone would get home safely, and we ask all this in your name. Amen. The last couple of weeks hit up on they're not on YouTube yet. They will be. I was told they will be. Okay. Because I didn't record it. Probably like give it a week or two. Well, Ray, he's got the camera. He's like, he's got the cameras up. You got it.
Chelsea with Lucer.